All right, we are up to number 18. And so we're going to be finding the equation of the parabola that has a vertical axis. That just means it's got a normal, y equals parabola. And has a vertex at -9, -8, and an x-intercept of 2. That means we know a point where our x-intercept, our x is 2, and our y is 0. So that gives us enough information to find the equation. So what we're going to do is we're going to work from our vertex form. Our y equals a x minus the x value from our vertex, which is -9. So it's going to be plus 9 squared minus 8. And what we're going to do is we're going to plug in our xy points so that we can solve for our a value. So my y is 0 equals a. My x is 2 plus 9 squared minus 8. So we have our 0 equals a times 11 squared minus 8. We could also just add that 8 to the other side. 8 equals 121a. So 8 over 121 is our a value. So to get our vertex form equation, we're just going to take this guy and substitute in our a. Y equals 8 over 121 x plus 9 squared minus 8. And that is question 18. Question 19. So we're going to be into our story problems now. We've got the newborn blue whales are approximately 24 feet long and weigh 3 tons. Young whales are nursed for 7 months, and by the time of weaning, they're often 53 feet long and weigh 23 tons. So we're going to have L and W are length and feet, while T is months and age. So L and T are linear related, so we're going to express L in terms of T. So we're just looking at the length. So they're 24 feet long when they start out new, and after 7 months, they are 53 feet long. So what that tells me is this gives me 2 points. At T0, y is 24. And at T7, it's 53. So if they are linearly related, that means we're looking for a line here. So let's start with finding our slope. So M equals, we're going to look for the change in y's, 53 minus 24 over 7 minus 0. So 53 minus 24, that's going to be 27, I think. No, 29. So I don't have any kind of calculator here. I had to take it home. 29 over 7. So that's our slope. And we can let it be like that. Because what we have here is M equals, or not M equals, our Y equals, or our length equals. Length equals 29 over 7 times T. Every month it grows 29 over 7 plus 24. That's the amount it started with at month 0. So that's a fine equation. As far as the daily increase for a young whale, then what we're going to do is we're going to take our 29 feet per 7 months. And what we're going to do is we're going to do a kind of unit conversion here. It's going to feel like it at least. 1 month has 30 days. Or it's going to move 29 feet in 210 days. And to get a numerical answer for that, we can go ahead and use a calculator. And I don't have a quick play to my calculator on the iPad right now. But we could type that in and get that number. We're going to do the same thing for W. So for W, they weigh 3 tons at birth and 23 tons at 7 months. So 0 months, 3 tons, 7 months, 23 tons. So our slope is 23 minus 3 over 7 minus 0. So our slope is 20 over 7. So our weight we can express as 20 over 7 times t plus 3. And again, similarly, to find our daily increase of the young whale, we're going to divide our slope into 30. So it's going to give us 20 over 210, because it's still by the 30. That one we can actually simplify with I. 2 over 21, 2 tons every 21 days. That's pretty fast. If you want to find out more about that, you could put the tons into pounds, and you could find out how many pounds they're increasing a day. But that's not what we're asking. 2 over 21 pounds per day, or tons per day. And then our last one here, we've got a car that was purchased 20 years ago for $35,000, and this year it's appraised at $7,000. We're assuming the value of the car is a linear function. So what we're looking for is at year 0, our car was worth $35,000. On year 20, our car was worth $7,000. So to find our linear function, we're going to do just like we did above. We're going to find our slope, 35,000 minus 7,000 over 20 years. So what we get is 28,000 divided by 20. Or 28 divided by 2 gives us 14. I'm just going to knock off one of those zeros. $1,400 a year. So our slope is that we have y equals minus 1,400. Oh, so that's v, because it's the value of our car. T plus, oh, I'm going to rewrite that because I'm super close to the edge and I can't make it expand over right now. So our value is, and it's decreasing here. If we wrote this full thing out, it would be 0 minus 20. So we have a slope of negative 1,400. So it's negative 1,400 t plus 35,000. Part B here is asking us to solve for a value. So we want to know after how many years it's going to be worth $20,000. So we want to know when the value is $20,000. So we're going to use our equation that we just wrote to kind of get an estimate on that. We're going to get close. So what we're going to do is we're going to start with subtracting 35,000. It's going to leave us with negative 15,000 equals negative 1,400 t. And divide both sides by 1,400, and we're going to get 150 over 14 equals t. And we can keep simplifying that. Divide by 2, and we're going to get 75 over 7 t. If we want a numerical answer, we can go ahead and long divide that. I don't have my calculator with me, or I would do it properly. So we're going to know it's be at least 10 years. 70 is going to leave us with 5.0. 7 goes into 50. 7 times, that gives us 49. So 10.7-ish years. So a little over 10.5 years. Okay? And we don't have to get super specific. 10.7 years is enough for me. Okay? We're not going to have to do tons of calculation like that. It's not going to be super calculatory like that. But I wanted us to see what those kinds of story problems look like. Oh my God.